In this video, I'm going to present about our project Intelligence Trap for an effective node-to-node communication under wireless ad hoc network. Team members are myself, Vinod Kumar R, Rajat Kumar, Surya P, Bharat S. This project is guided by Dr. T. Srihari, Professor EEE KSR IET. The actual problem is missing the people in hiking may cause due to the abnormal climatic condition or any other natural disaster in hiking spot. Religious ceremonies are happening frequently in India where there may be a possibility of losing a member in a crew in a denser crowd. The National Crime Records reported 228,650 crimes against women, including murder, rape, kidnapping, and sexual harassment happening every year. This problem may be solved by the solution like a mesh network, which is a local network topology in which the infrastructure nodes connect dynamically to as many other nodes as possible. The one node can send the data to the parent node or control node even if there is no possible connection with that node. The IP packet which you are going to transfer consists of node's location, person's heartbeat rate, oxygen saturation level, or person's body temperature. There are some existing systems which may solve the problem like LTE connected trackers, Bluetooth connected tracking devices, smart wearables, mobile application like Android and iOS. This is a block diagram of LTE connected trackers where the user equipment will collect vital body parameters like heartbeat, body temperature, and send it to the evolved node B. Evolved node B is a network infrastructure which is available for open public. Then it will send to the evolved packet core. Then it will send to the nearby evolved node B where the actual person is monitoring those data. Then it will send to the user equipment of the person. This is a block diagram of smart wearable where the controller will collect all vital body parameters like body temperature, heartbeat level, then step measurements, accelerometers, which will helps to know position of the body, then blood pressure. It will send those data via Bluetooth. It also displays those values using OLED. This is a block diagram of GPRS based tracking devices which will also work like LTE devices where the smart wearable collect those data, then you will send to the LTE device, nearby user's LTE device through Bluetooth. Then it will send to the cellular base station. The cellular base station will send those data to the network or exchange center. The exchange center will look for the person's nearby cellular base station. Then it will send those data to that. Then it will send to the actual person who monitoring the person. There are some disadvantages of public network based trackers. Some of them are LTE services may not be available in all cities. More towers and fresh technologies need to be developed for the better signal quality. LTE is costlier than GSM and Wi-Fi protocols. Bluetooth can lose connection in certain conditions. Bluetooth allows only short range of communication. Smart wearables have been reported to measure data inaccurately on some occasions. Our objective is to design the mesh network to enable effective communication between all crew members. To build robust, challenging, intense and high quality communication hardware with the range of 150 meters. To achieve the mesh network, which is also known as a MANET mobile ad hoc network using a Wi-Fi protocol. The operation of the hardware is transferring the data from one node to another node until it reaches the destination node. The data sent by the node can see only by the control node. This communication of the data from node to node can be done by using Wi-Fi protocol. The IP packet consists of node's location, person's heartbeat rate, oxygen saturation level, person's body temperature. The system enables the server node to have the data from every node. Data collected from the various sensors are converted into JSON as shown below. The data consists of the header consists of the device ID, which is an IP address of the particular device, a particular hardware, then temperature of that node, our average heartbeat rate, latitude and longitude. This is actual block diagram of the client node, which consists of a node MCU, which is in heart of this hardware, which is a Wi-Fi based microcontroller, which will collect the vital body parameters like body temperature via LM35 temperature sensor, max 30100, which will help to collect the heartbeat rate and oxygen saturation level, which is an I2C based sensor. Then Neo 6M, which is another microcontroller where the latitude and longitude, which is exact location of the person, will be collected and transferred through the serial communication to the node MCU. This whole hardware is powered by lithium ion, which is in Samsung's 18650 lithium ion battery. It can be charged by using TP4056 charging module. This is an actual block diagram of the admin node, where the node MCU is also here also the node MCU is used as a microcontroller, which is powered by Samsung's 18650 lithium ion battery. It can be charged by using TP4056. The OLED display is used here to show the all collected data of the nearby nodes. This is the actual circuit diagram where we can see the pin configurations of the heat module, node MCU, pulse oximeter max 30100, GPS module Neo 6M, temperature sensor LM35 and TP4056 charging module, then battery. This is a network mapping diagram which will explain the network mapping between the node to node communication. For example, node 1 need to send the data to the server node, but there is no possible wireless communication between those nodes. In that particular case, node 1 send the data to the nearby node, which is node 2 and node 3. Then it will look for the nearby node like node 5 or node 4. Then node 4 will send the data, collected data from the node 1 to the server node. The key thing is node 1's data can be only seen in the server node. No nearby nodes can see the data, but the data transfer is enabled by using the nearby nodes. This is the overall hardware setup. This is a node 1, this is a node 2, this is a server node. Each module is independently configured, independently powered, independently collecting the data. This is the output of LM35 temperature sensor, where the temperature in degrees Celsius and Fahrenheit and Kelvin can be seen. This is the output for the Neo 6M GSM module, where the exact latitude, longitude, time and date from the satellite can be shown. This is the latitude and longitude is mapped in Google Map. This is the hardware setup of our project, where the OLED display is showing the data from nearby nodes, which consist of temperature, nodes location, which is a latitude and longitude, then average body's heartbeat, which is compiled as JSON. Those data are serialized as a JSON from the nearby nodes, then deserialized by the admin node, then shown into the OLED. Those are self-diagnosing and self-configuring based network. If the one node is disconnected from the whole network, the other nodes are self-configured to serialize the JSON and transfer that. If again the node is reconnected to the infrastructure, then the whole node is reconfigured, then it will start to transfer the JSON data. Thank you.